Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEKS topic, graphing quadratic functions of the form y equals ax squared and y equals the quantity bx squared by transforming the parent function of y equals x squared. All right, so looking at this one, there's two things going on here depending on where that negative sign is. So if it is set up like this, where it's negative 1/2 x squared, so the negative is not tied to the x like it is down here, or more specifically tied to the squared, but then what that means is we're going to be flipping over the x-axis, so it's going to be flipping upside down. So the 1/2 tells us that however far away from the axis we are is going to get cut in half, and then the negative means it'll be on the other side. So to explain what I'm doing with that, I'm going to go ahead and take this one as an example, as I think it's an easy one to see. So it's currently 4 away from the axis. So I want to cut that in half, so I'm only going to go 2 away, but it's also on the other side. So instead of putting it 2 here, I'm going to go on the other side and go 2 down for this point. Okay. This one, I didn't pick because it's a fraction. This one's 9 up, right? So half of that is 4.5. So we're going to go, instead of going up 4.5, I'm going to go down 4.5. So 1, 2, 3, 4.5. It'll be in the middle there. This one is only 1 up, so that'd be down 1/2. This one's at 0, so I'm not going to do anything with that, which is kind of nice. So that stays there. And then this one would be mirrored. So this will be down 1/2 as well. This one's up 4, so we'll go down 2. This one's up 9, so we'll go down 4.5. And then when we sketch this one out, it'll look like that. Okay, so it doesn't look a whole lot different, but it is a little bit more wider than this one, so a little less narrow. Okay. Down here, a negative inside the square actually would be flipping over the axis like this. So in this case, it's actually not going to do a whole lot, but that's okay. So, because if we simplify this out, it would actually just come out to 4x squared, which is really all we're doing. So really all I'm doing is stretching this out by 4. So unlike here where I cut the distance in half, I'm actually going to be multiplying this distance by 4. So it'll be 4 times as big. So this is still 0, so it's not doing anything. This one is 1 away, and it's a positive 4, so I'm not going to go the opposite direction. I'm going to keep going up, since I'm going up 1, up 4, etc. here. So instead of going up 1, I'm going to go up 4. This one is at 4. I'm going to go up 16. That's not going to land on my graph. And this one's definitely not. So I'll go to the other side. This one's going from 1 to 4. This one's 4 to 16. This one's 9 to 36. So this is going to be a much narrower graph than the others, which is what you want to kind of keep an eye on here. If my number here is absolute value of it is between 0 and 1, your graph's going to kind of get wider. It's going to stretch out like this. If it's greater than 1, the absolute value is greater than 1, it's going to get narrower like this one did with 4. And the bigger the number, the narrower it is, or in the case of our numbers that are less than 1, the closer it is to 0. So if I was going for a smaller fraction like 1/3, 1/4, 1/5, then it would be even more stretched out as we go.